Ano, isang topic na lang naman continuation lang ito nitong power triangle. Gusto ko lang i-remind ulit yung discussion natin last meeting about dun sa kapag ang given ay hindi naka-sinusoidal or naka-phasor form. So, di ba sabi ko sa inyo, kapag ang given natin ay yung value lamang ng source, yun ay instantaneous, RMS value pa lamang. Hindi katulad nitong mga to, yan, kapag ganito yung equation natin, naka 100 sine 370 plus 30 degrees, yung 100 dito, ang ibig sabihin nun, that is the maximum value already. But, kapag ang given natin ay katulad nito, yan, yung 220 volt supply, ibig sabihin, yan po ay naka-RMS. Yan. So, kapag RMS po ang given, kailangan muna natin siyang i-convert papunta sa kanyang maximum value para magamit natin siya dun sa ating equation. So, ang Vmax ay equal sa square root of 2 ng V RMS or any quantity for that matter. Basta kukuhanin natin yung maximum value at RMS value lang yung given natin, edi i-multiply natin yun ng square root of 2. Maliwanag po? Maliwanag po ba?
Yes po.
Okay. So, pero basta ang given natin, halimbawa 220 bar angle 0 degrees, yan ay maximum na din kasi naka-phasor form na siya. Okay, so balikan natin yung ating naging discussion last meeting. So ituloy natin tong example number 3. So a load of 20 plus J35 ohm is connected across a 220 volt source. So determine the VARs or the reactive power Q. Yan. So paano natin ito solve? So una, tingnan muna natin. Yan. So edi 220 volt source ulit yan. So ibig sabihin ay hindi pa siya naka-maximum. Yan. So, anong gagawin natin? So, una, since ang load natin can be written in a form, so Z na agad yon. So, 20 plus J, 35 ohms. Ang hinahanap natin is the reactive power. So, to find the reactive power, that is, pwede natin gamitin yung equation ng power which is EI conjugate. Yan. So, sa EI conjugate, since wala tayong I, pwede natin palitan yung ating current with respect to Ohm's law. So, ang current, alam naman natin, that is E over Z. Yan. So, meaning, ang S natin dito ay pwede natin palitan. So, E multiplied by E, pero kailangan natin siyang i-conjugate divided by the Z conjugate. Yan. So, this will be so, E squared yon. Yan. So, isa ito sa mga pwede natin gamitin formula. So, kaya naman, pwede natin i-direkta kasi ang natin, di ba, J35 yon. So, ibig sabihin, since ito ay positive ang Q, reactive power natin, yan ay inductive. So, di ba sabi ko sa inyo, pag ang Z natin ay plus, yan ay inductive load. Pag yan ay minus, ay capacitive load. Yan. So, pwede natin gamitin ang current natin is equal to square root of 2 multiplied by 220 divided by Z. So, ano yung Z natin? So, 20 plus J, 35. So, ano yung value ng current natin? May compute po. Hindi ko po. So we have 3.8293 minus J, 6.7012 amperes. Yan. So, ang kailangan natin ngayon is kuhanin yung kanyang polar form. So, ipo-polar form natin yan. So, we have 7.7181 bar angle negative 60.2551 degree ampere. So, para makuha natin yung Q, so, di ba? So, ito yung ating angle theta. Yan. So, pabaliktad. So, dapat ito ay lagging. Dapat nasa baba.
Conception. Nadalangin ko lang yung nag-axle loading.
So, equals 60.6551. Yan. Tapos, so, di ba sa power triangle, kung halimbawa ito, ano natin, pwede natin makuha na ang Q natin, ang Q is equal to E times I sine of theta. Sorry, nakamute pala. So, yun. So, ang kinuha muna natin is yung value ng current. So, kapag kinuha natin yung value ng current, ang magiging value natin is 7.7181 bar angle negative 60.6551. So, kung ito-drawing natin siya dun sa ating triangle, so yung angle natin is nandito. Since yan ay inductive load, so laging yun. So, kapag ganito yung ating drawing. Tapos, ang diba yung voltage, kung ito yung voltage natin, tapos ari yung current, so the current lags the voltage by a certain angle. Yan. So kung ang ating ang value ng ating voltage ay 220, so diba yun ay square root of 2 times 220 by angle 0. So kaya siya nandito. Tapos laging daw yung ating current by 60 degrees. So, 60.3551. So, pag kinuha natin ang ating Q, pwede natin siyang kuhanin as for the equation EI sine of theta. So, kukuhanin natin yon. So, that is square root of 2 times 220 times 7.7181 times sine of negative 60.6551. So, which will give us the value. Paki-compute nga po.
2,093.24780 po. 2480. 2480 po.
2480. Yan. So, this is VAR. So, ibig sabihin, so this is an inductive or lagging. So, yan po yung ating magiging equation. So, any question? Okay. So, wait lang ha. May correction lang din eh. So, since ang current natin, so wala namang specified pala din eh kung ito ay maximum or instantaneous, RMS. So, dapat hindi na natin to i-multiply ng square root of 2. So, pwede itong direkta na. Yan. So, pagka nire-compute natin, ang magiging sagot dapat is 220, 20 plus 35 ay, so dapat yun ay 2 point, so this is 2.7077 minus J, 4.7385 amperes or 5.45. So this is 5.4575. Yan. Tapos, dito sa Q, hindi na rin natin siya i-multiply ng square root of 2. This is 5.4575. So that is 220 times 5.4575 times sine of negative 60.6551. So we have 1,000 46.5892 bars. Yan. So, yan dapat yung ating sagot. Kindly correct na lang po. Okay, next is the metering power of the metering of a power customer was read and gave the following data. So, ang kilowatt hour consumption niya is 20,000. Ang kVAR R is 180,000. Then, ang maximum demand daw niya is 380 kilowatts for a billing day of 30. So, what is the average power of the consumer? So, tinatanong sa atin is yung average power ng ating consumer. Average power factor ang hinahanap. So, kung average power factor ang kinukuha, so given na sa atin yung kilowatt hour, so 30 days daw yun ang ating billing period. Yan. As ang maximum demand daw niya ay 380 kilowatts. Paano natin kukuhanin yung kanyang power factor? So, explain niya paano natin kukuhanin. Any idea? Okay, so paano natin kukuhanin yon? So kung mapapansin nyo, ang given natin ay naka-kilowatt hour at saka kvar R. So kung sa power triangle natin siya titingnan, so di ba ito yung theta natin, then ito yung P, ito yung Q, ito yung S. Yan. Ang maximum demand daw niya ay 380 kilowatts. Ang billing days niya ay 30 days. So ibig sabihin, ang total number of hours natin is 30 days times 24. So ilan yon? That is 720 hours. Yan. So para makuha natin yung real power at saka yung Q, so ang power natin is equal to the energy over time. Yan. So which is 200,000 kilowatt hour all over 720, which will give us 200,000 over 720. That is 277.7778 kilowatts. Then for our Q naman, that is 180,000 divided by 720 hours, which is 250 kilo var. Yan. So, para makuha natin yung power factor, so ang power factor natin by using this is, ang power factor is equal to cosine of theta. Wherein, ang theta natin, so anong P at Q ang given natin, so anong pwede natin gamitin? Ang Q natin ay opposite, tapos adjacent. Ano ba ang opposite at adjacent? Jadi, ibig sabihin, tangent of theta. Tama? Opposite at saka adjacent is equal to opposite na Q over P. So, ang theta natin is equal to the inverse tangent of Q over P. So, ano yun? So, which is theta is equal to the inverse tangent of 250 over 277.7778. So, our theta is equivalent to 41.9872 degrees. And para makuha natin yung power factor, which is equivalent to cosine of theta, so i-cosine mo lang yung 9872, which will give us the power factor equivalent to, so we have 0.7433. Yan. So, yan po yung ating final answer. Any questions? Question po? Okay. Next. So, a 25 ohm resistor connected in series with a coil of 50 ohms resistance and 150 millihenry inductance. So, what is the power factor? Yan. So, kapag ganito, in series daw. So, kung ito-drawing natin siya, kung ito yung ating source, so, meron tayong 25 ohms, tapos may coil tayo na 50 ohms at saka yan. So, ito yung coil natin. Yan. So, ito yung 25 ohms, tapos ito yung 50 ohms, at saka 150 millihenry. So, assuming that our source is running at 377 radians per second, ano daw yung power factor? So, ang power factor ay pwede nating makuha using our given dun sa ating impedance triangle. So, diba sa ating impedance triangle, that is R, then we have X at saka Z. Yan. So, ito po yung ating pwedeng kuhanin. So, pwede din natin siyang kuhanin mismo dun sa impedance. So, kuhanin mo lang yung total impedance, tapos kuhanin mo ang kanyang equation form, then kung ano po yung angle doon, yun ang kanyang magiging power factor angle, tapos i-cosine mo lamang. So, pero bago natin makuha yung total um, impedance natin, kailangan mo muna natin i-convert yung inductance natin papunta sa inductive reactance. So, that is 377 times 150 millihenry, which is equivalent to, ano yan? That is 56.55 ohms. Okay. So, ibig sabihin, ang total impedance natin is equal to 25 ohms plus 50 ohms plus J 56.55, which is equal to 75 plus J 56.55 ohms. Then, convert this to polar form. So, ano yung polar form niya? So, we have 93.9303 bar angle 37.0163 degrees. And para makuha natin yung power factor, that is the cosine of the angle, which is 37.0163 degrees. Your power factor is equal to 0.00, which will give us the value so 0.7985. Power factor, so this is lagging. So bakit lagging? So bakit lagging yung power factor natin? Okay, so dahil siya ay inductive ang load. Okay, so any questions? Questions po? Yan. Okay, so yan. So yung last topic natin, para tapos na tayo agad. So ito yung last topic natin, conductance, admittance, and susceptance. So ang intended learning outcomes natin is to define what is inductance, admittance, and yan. So ito yung capital letter G ha. Capital letter G. Conductance, admittance, and susceptance, and its unit. Then appreciate factors that affect the conductance, admittance, and susceptance. So, conductance, admittance, and susceptance in series circuit. So, any series circuit containing resistance and reactance may be converted into its equivalent, a parallel circuit in which a resistance is in parallel with a reactance, and the fact that the parallel RX circuit is equivalent to the series RX circuit implies that both will take the same current at the same power factor from the same voltage source. So, referring to the voltage, to the figure on the next slide. So, ito daw yung ating magiging dito, equivalent. So, ito daw yon. Kung ito yung original natin na given, so, di ba ito yung ating source, tapos meron tayong series na impedance. So, ito yung R at saka yung XL natin. So, So, pwede daw natin yung palitan ng equivalent circuit na ngayon ay nakaparallel na yung ating magiging given. So, ano mangyayari? So, ang magiging in terms natin ngayon ay conductance at saka admittance. Susceptance. Okay. Yan. So, conductance and admittance. Yan. So, ito. So, parang ang magiging ano natin is i-convert lang natin itong dalawa. So, paano mo i-convert ngayon yung resistance at saka yung reactance mo into its equivalent. So, ang gagawin lang natin is i-reciprocal daw natin yun. Yan. So, pag sinabi natin conductance, it is the reciprocal of the resistance R and is given by the symbol capital G. Conductance is defined as the ease at which a resistor or a set of resistor allows a current to flow when a voltage, either AC or DC, is applied. Yan. So, di ba, ang resistance natin kasi, inire-resist niya or ini-impede niya yung flow of current. Pag conductance naman, ay di kabaliktaran noon. So, kapag ka-inductive ang load natin, ang G natin is 1 over R, tapos ang G of L natin is equal to RL over Z RL squared. So, ito ay yung resistance ng ating inductive circuit divided by the square of the impedance of our RL circuit. Then, kapag capacitive naman, edi yan. So, ang G, L, at saka C. So, RC over Z, RC squared. Then, pag sinabi naman natin susceptance, it is the reciprocal of the reactance and is given by the symbol beta. So, in AC circuit, susceptance is defined as the ease at which a reactance or a set of reactances allows a current to flow when a voltage is applied. So, kapag pinag-uusapan natin ay inductive, yan, so, susceptance natin is 1 over XL or, yan, so, di ba, ang XL natin is magiging 1 over J omega X L. Yan. So, yung J natin ay nasa baba. So, pag tinaas yung magiging negative. So, ang magiging ano natin dyan is negative XL over Z RL squared. So, kasi kapag ito ay kapag nasa equation form na siya, yan. So, magne-negative yan. So, kabaliktaran naman niya yung ating capacitive naman. So, si capacitive naman ngayon ang magiging positive. Then, si admittance naman is the reciprocal of impedance and is given by the symbol Y. So, in AC circuits, the admittance is defined as the ease at which a circuit composed of resistances and reactances allow current to flow when a voltage is applied, taking into account the phase difference between the voltage and the current. So, kapag inductive circuit, so di ba ang ating admittance is kabaliktaran daw ng impedance. So, that is 1 over Z. So, yan. So, ang Z natin ay ang Z natin ay R plus J XL. Yan. So, kapag kinonvert natin yan papuntang admittance, ang magiging ano niya is conductance minus J susceptance. Yan. So, kabaliktaran. Kasi ay nasa ilalim yung Z, so magne-negative yan. Sa capacitive naman, edi baliktad. So, di ba ang Z natin kapag capacitive ay R minus JXC. Kaya pagka ni-reciprocal mo to, so ito yung lalabas natin. So, ang pagre-reciprocal po dyan ay as a whole, as an impedance ha, hindi yung gagawin mong individual na 1 over ganyan. So, as a whole po. Yan. Tapos, ito yung magiging triangle natin ngayon. So, kung ito yung impedance triangle natin, ito yung R, ito yung X, ito yung Z. So, sa admittance, baligtad naman. So, ito yung conductance natin, ito yung admittance, at ito yung susceptance. So, ano lang naman sila? Reciprocal lang nung isa't isa. So, para mas maintindihan nyo, halimbawa ito. Parallel circuit consists of a resistor having a conductance of 4 mhos, yan, and an inductive reactor having a susceptance of 8 mhos and a capacitive reactance having susceptance of 5 mhos. What is the impedance of the circuit? Yan. So, para makuha natin yon, ang kailangan muna natin is yung total. Ang hinahanap is impedance. So, kung impedance yan, ibig sabihin that is the reciprocal of the admittance. So, paano natin kukuhanin yung admittance total? So, ang admittance total is equal to the G total plus or minus J susceptance total. Dito si total ano. Yan. So, given na naman sa atin yung yan, a resistor daw having a conductance of 4 mhos. Ibig sabihin, ang G total natin ay 4 mhos. Tapos, ang inductive reactor daw natin, so ibig sabihin may beta L tayo na 8 mhos at a capacitive reactor naman daw na 5 mhos. Yan. So, paano natin kukuhanin? So, ganun pa rin naman. So, in this case, mababaligtad din yung ating convention. So, ang L natin ngayon ang magiging negative at ang C ang magiging positive kasi ni-reciprocal na natin yan, di ba? So, ibig sabihin, para makuha natin yung G total, so that is 4 minus J8 plus J5, which will give us the total admittance of 4 minus J3 mhos. Yan. So, ulit. So, bakit ganito ang naging annotation? So, di ba, kapag ka yung kapag ka ang pinag-uusapan natin ay impedance, di ba yung inductive impedance, pag inductive, yun yung positive, tapos kapag ka capacitive, yun ang negative. So, mababaligtad siya kapag dito sa admittance. Yan. Tapos, para makuha natin yung ating Z total, so that is the reciprocal of 4 minus J3, which will give us the final value of, okay, compute nga. So, the answer is, yan. So, 0. So, ang total impedance daw natin is 0.16 plus J, 0.12 ohms. Yan. So, kung mapapansin nyo, yan, nag-positive na siya kasi ito ay magiging inductive reactance na. Kasi kita naman din na mas malaki dapat yung, or yun dapat yung magiging resulting impedance. Kailangan ay naka-inductive. Maliwanag po. Any questions? Clarifications? Okay. So, yan. So, that will be the coverage of our final exams. So, pamula dun sa ating introduction dun sa AC circuits, dun sa mga terms like yung mga amplitude, yan, yung sinusoidal, yan, yung mga wave, yung waveforms, formula ng RMS, formula ng average, maximum, tapos yung RL, RC, at RLC circuits, tapos impedance, tapos itong admittance and power. So, yan po yung magiging coverage ng inyong final exam. Then yung ating problem set, so naibigay ko na naman yung problem set sa inyo, di submit na lang po on the day of the exam. Okay? So, may questions pa po tayo? Clarifications with regards to ano? Kasi kung wala, then I think that will be all for our topics for this semester.